This is 2018 paper 1. This question is about iron and its isotopes. State in terms of fundamental particles the difference between the two isotopes of iron. The difference between the two isotopes of iron. Of course, what is the difference between the two isotopes? Like what thing is different in terms of subatomic particles? If you remember the definition of isotope, so we used to say that the number of electrons and protons are same, but the number of neutrons are different, right?
Yep.
So I can say different number of neutrons.
Okay. Uh,
State why
same
different
number of
isotopes
different.
of iron have the same chemical properties. Of course, I can say same number of electrons. Chemical
Partial
property
electrons.
is due to the chemical property is due to the number of electrons. Okay, or I
Due to
can
the
say
additional electrons, or like
same
just electrons?
electronic configuration.
Oh, okay. All right.
So a sample of iron was ionized in a time of flight mass spectrometer. Okay, by electron impact. Write an equation including state symbols for this ionization. So we have iron. We have iron. So of course, when I would be entering the sample in a mass spectrometer, which would be like there would be a bombardment of electron to the sample, high energetic electrons. So of course, electron would be removed from the sample and iron would be having a positive charge like that in the form of in gaseous state, and this is iron gas, and this is iron gas. First
Okay.
of all, the sample should be vaporized. First of all, the sample should be vaporized. After vaporizing the sample, then we have to ionize the sample. That's the, you can say, like these are the steps when you are going to put anything in the mass spectrometer. First of all, you have to vaporize the sample and then you have to ionize the sample. Okay?
Okay.
Yes. So, okay. Now see this one.
Yeah.
Calculate the mass number of this iron. How you would be doing this? Mass of iron. Of course, it's gonna be around 50 because if you can see the periodic table, the mass of iron is 56.
Hmm. Okay. So we need to we have the kinetic energy. We have the velocity as well. We can calculate that by because we have the time and the distance. So we can get the speed by dividing the distance by the time, and that would be our velocity. And yeah, Ke is kinetic energy, right?
So what
So
would be the answer?
yeah, I'll just find that.
So you have to find out the m, right? You have to
Yeah,
find out the m. So first of all, you need to know the velocity.
I found out the velocity.
Yeah.
1 second. The answer that I'm getting is, I'll just tell you. It's loading in the calculator. 1 second. What I did was uh 0.857 divided by 2.01 times 10 to the power of negative, sorry, no, 0.857 divided by 1.28 times 10 to the power of negative 5, and then I equaled it to square root 2 multiplied by the kinetic energy given,
Mm-hmm.
which is 2.01 times 10 to the power of negative 16,
Hmm.
and divided that by m, and then I would find m by making it the subject.
Yeah, okay. So what's the answer? Method is correct, okay.
Yeah, okay, wait.
So 5 marks. Oh, okay.
Yeah, I'll have to do it. 1 second. Uh, I just tried using the shift calc solve thing, but then it didn't work, so I'll have to do it again. Like, I'll have to take everything to one side and do it. 1 second. Okay, so it's gonna be 2 kinetic energy, like 2 multiplied by the kinetic energy, and then I'll divide that by the distance over time and whole square that. I'm not getting the answer.
First of all, what you did?
Yeah, okay, wait, no, I'm getting 8.9, 8 point, no, like 8.97, 8.97 times 10 to the power of negative 26. If I just make the mass the subject,
Hmm.
like the mass that I'm getting is this, what I just told you.
What's the mass?
8.97 times 10 to the power of negative 26.
This is your final answer, right?
No, no, this is the mass, just the mass.
Okay.
I need to find the mass number, right?
Yeah,
MR.
exactly.
So
Mass number.
I don't know if is my mass correct?
8.9, you're saying, right?
8.97 times 10 to the power of
Yeah.
negative 26.
Yeah, that's correct. Okay.
Okay, so now, sir, this is what I was saying yesterday. Like, I needed the formulas for the mole zone. I don't remember how to get the mass number using the Avogadro's
You
constant.
have to, yeah, you have to multiply this by Avogadro's number. You will be getting the mass number.
So mass multiplied by Avogadro's number will
Yep.
give me the mass number. Okay, multiply this by 6.02 times 10 to the
You
power.
have to convert it in kilograms because they're saying mass of the iron, mass of the ion in kilograms. So of course, what you are supposed to do then? 10 to the power 3.
Yeah, multiplied by 1,000.
Yeah, multiplied by 1,000. Kilograms to
Wait, not,
grams.
won't you divide it? We
No,
have it in
kilograms
grams.
to gram.
Sorry. Oh, we
So
have it in kilograms. Right, right, right.
yeah,
Multiplied
exactly.
by 1,000. 53.98.
Exactly. Good. It's equal to 54. So first of all, you found the V. Am I right?
Yeah, I found the V. No, I
So
found
how
the
did you
M.
find?
Oh yeah, V. Right.
So V is equal to what? V is equal
S-
to distance
What
upon time.
what I did was instead of that I first made M the subject in this case. So
Yeah, same thing.
V's,
So
and
you
then
did
I
like that.
changed V to D over T.
V square is equal to 2ke by M, isn't it? Then M
Yep,
equals to
exactly. And then we cross multiply.
2ke then over V square and then 2 into
Yep.
kinetic energy that is given to you that is 2.01 exponent minus 16, isn't it?
Mm-hmm. Yep,
And
yep.
then what about V?
V is D over T, distance over time.
Yeah, exactly. So 1.28 exponent minus 5 over time, that is 0.857. No, sorry, 0.857 0.857 meter divided by the time, that is 1.28 exponent minus 5. Then you got M, right? What's the M?
Um, I got M as 8.5 times 10 to the power of negative 26, something like that. Something
It's
like
in
that, I'm not sure.
kilograms. So then I have to multiply this by 1000.
8.96, 8.97, 8.97.
Okay. So I have
Then
to
yeah,
convert it in grams. So then I have to multiply this by Avogadro's number. So I would be getting the mass, that is what you are saying, 53 point something, I think so. No?
uh, mass is the final answer is 53.98, 99, 53.99.
So it's approximately equal to 4. It's approximately equal to
Yeah,
54,
50.
right?
Yep.
Okay. Iron reacts with dilute hydrochloric acid to form iron 2 chloride and a gas. Write an equation for this reaction. So iron, that is Fe, it's going to react with HCl. It's gonna form iron 2 chloride, that is FeCl2, and hydrogen. Yeah, hydrogen gas. Equation is now balanced. Yep. Iron forms the compound iron 2,3 sulfate. What's the formula? Okay. So what's the formula? It's easy.
Um,
Mhm.
Iron 3 sulfate. Uh, okay, wait. Fe, like, we'll do the cross thing. So Fe is 3 and sulfate is SO4 2 minus O2. Fe2 SO4 3. So Fe2 SO, it would be the second one.
Exactly. Good, 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 good. This question is about reactions of inorganic compound. Okay. What is observed? What is observed? So they are saying that to distinguish between barium chloride. Okay. To distinguish between barium chloride and a magnesium chloride. So how can we differentiate? It's
Uh,
very easy. Mhm.
Sulfate or something? I don't
Yeah,
know.
exactly. Because in the case of barium chloride, it would be forming barium sulfate. You can see the white precipitate, but in the presence of magnesium sulfate, we can't see the precipitate because the solubility of sulfate decreases down the group.
Yeah,
Okay, so the one which is on the above the group would be completely soluble. So that's the difference between these two. So I'm supposed to write reagent. I'm supposed to write
wait, so you're saying
so
with
the
the barium
Na2
chloride, it's gonna form, sorry? Okay,
white PPT
okay.
of barium sulfate. White PPT of barium sulfate and colorless solution for magnesium chloride. A mixture contains solid sodium carbonate and solid sodium sulfate. Describe how a pure sample of solid sodium sulfate can be obtained from the mixture. Can be obtained from the mixture. It's a part of 2. So 2.2. A mixture contains solid sodium carbonate and sodium sulfate. I mean to say 2CO3 or Na2SO4 mixture I have. Describe how a pure sample of solid sodium sulfate we have to obtain. Like I have to obtain this one from the mixture. So what should I do?
Um,
Again the same thing. You have a sulfate. Again the same thing.
so
You
just
have
use
a
sulfate
sulfate.
again.
So you are supposed to add I can say uh you are supposed to like add sulfuric acid, I can say, isn't it? I can add sulfuric acid. It would be reacting with Na2CO3. That's a base. It would be releasing carbon dioxide. It would be forming salt. That is sodium sulfate and water and water. Okay. So then you have to evaporate. Then you have to evaporate it. Okay. Then you have to evaporate it. Then you will be getting your salt. That's it. So I'm supposed to write that add add sulfuric acid to the mixture, add sulfuric acid to the mixture. Okay. So then um, basically the thing is that H2SO4 will react with Na2CO3 will react with Na2CO3 to give carbon dioxide, Na2SO4 and water. Na2SO4 and water. Okay. So
Okay.
you are supposed to add more and more acid until the effervescence stops. What does it mean until the effervescence stops? All the carbonate has been reacted, isn't it? All the
Yeah.
carbonate has been reacted. So I'm supposed to write add excess H2SO4, add excess H2SO4 until effervescence until effervescence stops. Okay, so means that all the sodium carbonate has been reacted. So you can separate sodium sulfate. You can separate sodium sulfate So then you are supposed to evaporate. Then you are supposed to evaporate to dryness. Evaporate and then dry. Evaporate until the sample dry. That's it. In this way, you can separate the pure sample of solid sodium sulfate can be obtained from the mixture. Okay.
Okay.
Yeah. Okay. Okay. 2.3. I student adds. Okay. Okay. Complete the diagram to show the apparatus the student could use to measure the volume of gas collected. So what I'm supposed to draw.
What is at the bottom?
It's a magnesium ribbon. It's going to
Oh,
react with HCl. Of course, hydrogen gas will be released. They are saying, how can we collect the hydrogen gas from this flask? Of course, I'm supposed to collect the gas in a syringe, isn't it?
yeah, gas syringe.
Yeah, exactly.
So you can connect like a gas syringe and check the volume
And
of gas that's in the syringe.
yeah, so I can
Because
say that it's gonna be okay. Then what they are asking, show a graph. Okay. A student repeats the experiment with 60 centimeter cube of this one rock curve on a figure 1. Show how the volume of gas changes with time. Yes. They are saying 60 cm cube of 0.5 mole per dm cube hydrochloric acid. So this graph is drawn with how much concentration? 1 mole per dm cube and 20 centimeter cube. Okay. 1 mole per
okay,
dm cube and 20 centimeter cube. Now they have increased the volume and they have decreased the concentration. So of course the rate of reaction should decrease, isn't it? So the rate of
yeah,
reaction should decrease. So they are asking to draw the curve again. So then
but they have
how am
increased
I
the
supposed to
volume,
draw?
right?
Yeah,
But
exactly.
they have, so wouldn't that mean that the rate of reaction increases with increased volume due to more particles or
When the
something?
volume is higher, so the distance between the particle is higher. So the collision is lower. When the collision is lower, so the rate is lower, isn't
Oh, I
it?
thought like, oh, okay, okay, got it. Right. I thought because like there's more of it, so then like concentration. Okay, never mind. Right. Okay. All right. So you, if it's gonna be lower, then you're gonna draw a graph with the like with a bigger curve basically. Like from 0 to like 200 or something, it's gonna be like
It
curved,
would be
like till
it would be
250.
like that or it would be like that. Red or blue? Upper or lower?
Blue, 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 blue.
Yeah, good one. So less steep.
Yeah.
It would be less steep like that, isn't it? Like that. Yeah, good one. Okay.
Yep.
And then the student repeats the experiment but heats the flask containing the acid to 60 degrees Celsius before. Why the reaction is much faster when heated?
Um,
Then what you will say?
this is because the particles have higher kinetic energy, and they're yeah, because they have higher kinetic and the activation energy is like met. Like more particles, a higher proportion of the particles have energy greater than or equal to the activation energy.
There would be more
I think that would
particles.
be
There would be more particles whose energy is
higher
greater
proportion of
than,
the particles with energy greater than or equal to the
yeah,
activation energy.
whose energy is greater than the activation energy. So greater proportion of a successful collision in a given time. Okay. Okay. See this? This is easy. So 3 marks.
Yeah, um an aqueous mixture has okay. Uh okay, so they're saying that 0.30 is both C and D, right?
Uh, no.
Or like okay, so A and B is equals to C and D basically, like the total. Or
No,
I'm
no.
not sure. I don't know how to do this.
Okay, see this.
Yeah.
Real amount reacted, amount produced, equilibrium amount. So 0.510 mole of A and 0.195 mole of B is allowed to reach equilibrium.
Uh, amount. What's the first one? Amount. The second one is amount reacted, amount produced, right? What is IAARAP? Could you repeat? Mm.
So x would be equal to 0.030 minus 0.0195.
Okay.
What's the answer for x?
I can't see your screen.
This one.
Yeah.
What's the answer for x?
Oh, wait, I didn't calculate it. X is 0.0105.
0.0105. Then what am I supposed to do? I will be putting x over there to get the equilibrium amount
Right.
multiplied by 0.0105. Same goes for
Can you
this one.
summarize?
Same goes for
Um,
this
sir,
one. That's
could
it.
you could you like summarize real quick? What did you do here? Like, did you just add all of them or something?
No, I
Like
didn't
in the
add.
table?
No.
Then,
Basically,
like, how
this
did
is
you
the
do
initial
this?
amount.
Okay.
This is the initial amount. First of all, you know the formula. Equilibrium amount of the reactant side is equal to IA minus AR. Equilibrium amount of product is equal to IA plus AP. Then what I did, initial mole, how much moles have been reacted, 2x and x? How much amount produced, x and x? This is the given amount of B at equilibrium. I wrote.
Wait, wasn't the
Then
2x? Wasn't the 2x?
this, oh my God. Yeah, nothing to do with this. Of course, if you are supposed to multiply this by 2, it's 2x. That's it.
Okay.
Okay. Because we have to find out
Okay.
x from the B. X is correct. When I found x, I have put x over there. I got the values of D, C, B, and A. That's it.
Right. Okay.
Yeah. So it's gonna be, what's the answer of A, B, and C so that I can write?
A, B, and C. Uh,
Mhm.
okay, I found the X. One second. Z 1 second. The first one is two, like the that one is 0.489. I think that would be A, 0.489.
0.89.
489, yeah. And the 2D is 0.0105 times 2, which is 0.021. And C you already have.
C is what? 0.0105.
You said that, right? It's written. Because it's only 0 plus x.
And it's the multiple of 2.
Right. And the other one is 0.021, I think.
0 point?
0.021.
Okay. Let me check the marking scheme. Is the answer correct or not?
Right.
No, the answers are not correct. The answers are not correct.
Okay, why is that?
A is A is A is 0.180. A is 0.180. Hopefully this is incorrect. That's why I'm getting A wrong. X is incorrect. Can you tell me it again? Is that correct?
Okay.
0.0. Oh my God. It is
Uh,
0.195. Oh, ho, 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 ho. It's
0 point,
0.195. I wrote 0.019. Bhai.
okay. So
Okay.
0.030 minus
0.195.
0.195. So that's going to be negative 0.165.
Basically, the thing is that wait. X
Okay.
is equal to this one, like that.
Right.
Yep. Then what's the answer?
So that's going to be 0.165.
0.165. Then you
165.
have then you have to put it in this one.
Right.
So then what's the answer?
Um, First one is 0.18.
Yeah, it's correct now.
0.18. Second one is going to be 0.18. The last one, D, is going to be 0.36, and C already have 0.18.
That's correct. So C is what? 0.165, the same.
0.18. Sorry, 165. Yeah.
And this one is 0.33.
Oh, which one?
Okay.
0.36.
D.
0.36.
Because yeah, 0.3336.
Yeah, 36.
2x. It's 2x. 2 into
Yeah, yeah.
0.165.
0.18 times 2 is 0.36.
0.18 not.
Oh, wait,
0.165 times 2.
0.165. Right, right. Sorry.
Yeah.
0.165. Okay. Right. So 0.33.
Okay, Kc is equal to product upon reactant. Yep. The total volume of the reaction mixture is not known. State why the value of Kc can still be calculated. Because we have to put we have to put the concentration in Kc. We have to put the concentration in Kc. Concentration is mole upon volume, but the volume is not given. They are saying that without volume we can calculate Kc, but why? Because you
Um,
can see 2 and 1, the
right.
ratio is the same. They will be canceling each other. They will be the thing is that mole over volume multiplied by mole over volume times 2, then mole over volume times 2, mole over volume, 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 cancel, 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 cancel. So the mole remains. So we can calculate Kc without volume, but only in this condition. But only in this condition. Otherwise, if the coefficients are different, so you have to know the volume. Without volume, we can't calculate Kc. But in this, we can calculate because the volume cancels each other, isn't it?
Okay. Yeah.
Okay,
Okay.
see this one. It's the same.
Um,
A different mixture of A, B, C, and D is allowed to reach equilibrium at a different temperature. So that reaction, okay, temperature is not, you can say, is not depending on basically the answers. This new equilibrium mixture contains this much moles. Equilibrium at this temperature, the value of Kc is 6 point. It's very easy. It's very easy. You can do this in a minute. Kc is equal to the same formula. That is this one. Oh my God, no. C, then D, then A. Kc is 6.8 is equal to C is 0.842 times, D is 1.28 square, and x square we have to calculate A, that is square, multiplied by B, that is 0.180. So what am I supposed to do? A square is equal to 0.842 times 1.28 square divided by 6. So what I am supposed to do? Like that. So there would be the answer. Isn't it? It's very easy. It's very easy. Okay. Mhm.
okay.
Yes.
The square roots can be cancelled out, yeah? So
Yeah.
a square. So yeah. Okay. The answer that I'm getting is 1.09. 1.093. 1.093.
Okay. Yes.
Electronic configuration. Okay. Nitride is what? What's nitride? Lithium or nitrogen, right? Yeah. So nitrogen is 1s2, 2s2, 1s2, 2s2, 3s, no, 3p, wait, 1s2, 2s2, 3p1, right? No, 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 sorry. 1s2, 2s2, 3p3, I think, if I'm not wrong. Yep. Can you write
So
that
you are
down?
saying that,
1s2, 2s2, 3p3 is the electronic configuration.
so the total is 7, isn't it?
Yep.
The total is 7. But the thing is that they are saying that it's a
2p3.
nitride. No, they are saying nitride ion. Nitride means what? It's
Also
having
1s2,
minus 3
2s2,
charge. So 1s2, 2s2, 2p, 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 6.
2p6, yeah. Three more
7,
electrons.
8, 9, 10. 3 more electrons.
Yep. Okay.
What's the formula of lithium nitride?
Um, one second, I'll tell you, one second, one second. Lithium is uh, Li and N, 3 minus, so 3 minus Li3N. Li3N. Li3N.
Good. Li3N. Because lithium is in group 1, nitrogen is in group 5. So group 5 valency is 3. We are supposed to swap the numbers. I would be getting Li3N. Okay, so we have to swap the charges. We have to swap the charges, right? And also is an ionic compound. Lithium is +1, nitrogen is -3. So they will be attracting each other because it's an electrostatic force of attraction between the oppositely charged ions, right? It's the electrostatic force of attraction between the oppositely charged ions where the lithium is +1 and the nitrogen is -3. Okay, so they would be attracting each other. They would be attracting each other to form, they would attract each other to form the compound that is Li3N.
Okay.
Opposite charge. Okay. So in terms of structure and bonding, why the boiling point of hydrogen is higher than the boiling point of nitrogen? It's very easy. It's very easy.
Okay. Maybe due to stronger forces of attraction. Um, like the intermolecular forces between hydrogen is, I think, hydrogen bonding. Is that right?
Yeah, because if you remember, it's the bond between hydrogen and phone. Highly electronegative elements are three: fluorine, oxygen, and then nitrogen. Okay.
Yeah. So that's why I
So,
think it's
and what about
hydrogen
nitrogen?
bonding. So nitrogen is, I think, this is what you call permanent dipole-dipole forces.
Permanent dipole-dipole forces.
Yeah. Or is that wrong?
Yeah. Permanent dipole or a
That's right.
van der Waal, like a London force.
Which one is between like Cl2 or like Br2? Which one is between them? Van der Waal forces or like dipole-dipole?
Basically the thing is that if you can see that we have a non-polar one, so you can say it's a temporary dipole. It's a
Hmm.
temporary dipole like a London force, and if you have a polar molecule, then there would be a permanent dipole. Okay.
So this is temporary dipole, van der Waal
Yeah,
forces.
as we know that nitrogen is a non-polar one. That's
Okay.
why. So I'm going to summarize it. It's going to have hydrogen bonding. It's going and it's going to have a simple London force. And we know that hydrogen bonding is stronger, isn't it? Then London force. It's a weaker. It's a weaker bonding. Okay. So yeah. So they are saying it's structure and bonding. Structure and bonding. So why the boiling point of hydrogen is higher than the boiling point of nitrogen? Both are covalent. Both are simple molecule. Both are covalent. It's a covalent. It's a covalent. Also a simple one. Simple molecular. And hydrogen is also a simple molecular. Hydrogen is also a simple molecular. So, but the thing is that then we have to see the type
Okay.
of intermolecular force. Since we know that there were three types: temporary, that is called London force; permanent, and hydrogen bonding. So hydrogen bonding is stronger. That's why the boiling point of hydrazine would be stronger than the boiling point of nitrogen. Okay. Draw the shape of ammonia. Include any lone pairs of electrons that influence the shape. Yeah. So you know that nitrogen is in group 5. Nitrogen is in group 5. It's going to have 5 electrons, 1, 2, 3, 4, 5, like that. It's going to have 3 hydrogen atoms. It's going to have 3 hydrogen atoms like that. This is the electron of hydrogen. This is hydrogen, and this is hydrogen, right? So this is the lone pair of electron. Yeah.
Mhm.
Include any lone pairs that influence the shape. The lone pair is going to repel the bond pairs. The structure in which there would be minimum repulsion and maximum attraction, that structure would be more stable. Remember, the structure in which there would be more attraction and less repulsion, that structure is more stable. Okay. So the thing is that when ammonia would be having one lone pair, it would be repelling the bond pair. As a result of this, the structure would be getting its permanent shape in which the bond angle would be 107 degrees, and that would be called a pyramid shape. It depends upon the bond pairs and the lone pairs of electron. Are you getting my point? Yes?
Yeah.
Yeah. Okay. So ammonium ion, they are asking to draw dot and cross diagram. As we know that ammonium is NH4 plus. How the ammonium is formed? When ammonia form dative bond with hydrogen.
If you remember, electron of nitrogen, electron of nitrogen, electron of nitrogen, electron of hydrogen, electron of hydrogen, electron of hydrogen, and we have the fourth one, hydrogen, in which I can write down the dots. Two dots. What it's going to show that nitrogen has donated its pair of electron to the hydrogen. You know,
Hmm.
this is known as dative. This is known as dative bond. If you remember, it is called covalent bond. Am I right? Yes or no?
All right. Yeah. Okay.
Okay.